What's up guys, I'm Drizzlehop and today I'm going to go over some of the tolerances for the original Maslow CNC design. Check it out. To start off, I created a standard tolerance test, which is just a circle inside of a diamond inside of a square. And I plan to actually do just this for the outer edges of the Maslow. And in the inner side, I'm actually going to do a circle inside of a diamond inside of a square, inside of a larger circle, diamond, and square. From there, I'm actually going to go into CAM and Fusion 360 and generate the G code that I need to cut this on the Maslow. This is one of the first times I've actually used CAM and Fusion 360, so I had a lot of help from my friend Winston Moy, and I'll link his page below. And on a second page, there's going to be a full video dialogue between me and Winston on how to actually generate CAM for this test. And this is just the beginning. There's going to be several more instances of this coming out in the future, so be sure to check out that page if you want to learn a lot more about CAM. From there, I generated the G code and imported that into the ground control software. To give you guys an idea of how I'm going to do this test, I'm actually going to do a small tolerance test at all the corners of the 4x8, and I'm going to be doing these about 10 inches in from each of the corners to really test out the tolerance of the Maslow at those corners. And then I'm going to do the larger tolerance test. That's the circle inside of the diamond inside of the square inside of another circle, diamond, square right at the middle of the plywood. To give you guys a heads up, I do have a lot of user errors throughout this entire process. During the CAM creation, I must have forgotten to remove the corners in the actual milling out. So I have these corners at all the edges of the square, and I also forgot to add tabs in. So this part actually became loose at the end of the cut, and it must have hit the router bit when it became loose and added this hole that was unexpected. So I ended up changing that later on, but there's still a lot of user errors that you'll see that made this a lot rougher of a cut. However, this will still do for all the measurements I'll need for the tolerance test. As always, my dog Cyrus wanted help out with this project, so here's a quick dog cam for your enjoyment. I then moved on to cutting out the larger tolerance piece for the Maslow. This had a lot of unforeseen parts on my end because of how the Maslow actually operates. Since I cut the outer border of the tolerance cut first, the sled actually caught that border and kept pivoting off of it and ended up moving away from the plywood. I ended up chiseling out the border so that the sled could move easily over during the cut, but I'm actually going to smooth out the edges of the sled so that this can move over it easily in future cuts, and I'm going to plan this out in my future projects so that I'll end up cutting the inner sides first, and hopefully this won't happen in the future. I'll make sure I work with Winston on our future videos to talk about how we can efficiently plan for these type of cuts with the Maslow using CAM, so make sure you check those out. Now let's review what I had modeled in dimensions and what the Maslow was actually able to cut. For the inner square, I made it 2 by 2 inches, and for the diamond, it ended up being about 1.4 by 1.4 inches, and the inner circle diameter was also about 1.4 inches. For the smaller cut, I made the depth of each cut about 0.2 inches, and then for the larger cut, I kept the inner dimensions the same except for the depth being 1 inch across each layer. And then for the outer square, I made it a foot by foot, and then for the diamond, it was about 8.5 inches by 8.5 inches. And then for the diameter of the circle, it was also about 8.5 inches. I then took each of the pieces that was cut with the Maslow and measured them with a digital caliper. I'm going to show the results of this in an Excel spreadsheet at the end of this video so that you can actually compare what was modeled versus what was actually cut. But the key takeaway was that the original Maslow wasn't too bad with tolerances. The highest error rates I saw were about 5 to 6%. Now this is definitely not something you can take out of the box and use right away as other CNC machines you might buy. It's definitely going to be something you have to play with to improve on the tolerance, but I'm curious to see what the new Maslow design is going to be able to provide, so make sure you guys keep an eye out for that. Alright guys, so I hope this video was helpful for you. Just to go over some things for the Maslow design, some of the issues were based off my user experience and lack thereof of using cam before in any CNC machine. So I will be improving over time. I'll be working with my friend Winston, who's very good at CNCing. His page is Winston Makes, and I'll link it down below for you guys to check it out. He's actually gonna have a second video channel where he's gonna post some talks between me and him, where he's actually guiding me through using cam for generating the cuts for this Maslow. So make sure you guys check that out. If you guys are interested in finding out more about the Maslow CNC, I'm actually planning to do a live broadcast where you guys can actually ask me questions directly, and I'll go over whatever you guys want during that. So if you're interested in that, go ahead and comment below and let me know. All in all, I'm still pretty impressed with this Maslow. There's gonna be a lot of improvements based off the new design that they just released. So I'm actually gonna be upgrading my Maslow CNC machine. So make sure you guys check out that as well. If you guys wanna see more videos like that with the new Maslow or any of my other cool projects, make sure you guys subscribe to my channel. If you like this video, go ahead and like below. And if you have any questions or comments, again, go ahead and comment that below. Thanks again for watching, guys.